All right, so this lesson is section 2 of chapter 1, and it really talks mostly about slopes of lines. So let's review this equation here. This is slope-intercept form. Again, our text calls it standard form, but we're going to call it slope-intercept form because really it gives us the slope and the intercept, the y-intercept. And x and y, what x and y are, they're points on the line. So if I get an x value, it'll spit out a y value and vice versa. So first off, m is our slope, and we'll talk more about slope on the next slide. And then b is our y-intercept. And then our y-intercept is the point, I should maybe do this, is the point 0, comma b. All right, so if at the end of that equation it was said -1, then your y-intercept would be 0, comma -1. If at the end of the equation it said +8, then your y-intercept would be 0, comma 8. All right. Okay, slope. So now what we have is we have our slope, and in our slope we have the basic way of doing things, and it's rise over run. That's probably the more easier way you may have learned a while ago. So you have rise over run. So the difference of your y values, which is what this triangle here is, delta is the difference. So the difference of your y over the difference of your x's. And then we have y2 minus y1 over x2 minus x1. Now, where do these values come from? This y2, y1, x2, x1. Where it comes from is it comes from these points, and they're just arbitrary point values here for our purposes. But when you look at this, what it's saying is, notice how the x1 and the y1 come from the same point. This is one point right here, and then x2 and y2 come from the same point. What it's really identifying is those y2 and x2, you can see right here. These are the x and y values that come from the same point. In this case, it's going to be this point. y1 and x1 are the x and y values that come from this point here. That's really why. That's really what the subscripts of 1 and 2 really are what they're there for. It's that way you don't get them all cross all over the place. All right, so let's get into our first example here. So let's just find the slope between 2 points. So if we follow our formula, it says m equals, and we're going to say x2 minus, y, my fault, y2 minus y1 over x2 minus x1. And again, it does not matter which one we choose to be the first point and the second point. As long as we get them consistently in the formula, then we'll be good. They'll all work itself out. So let's just say that this one is our x2 comma y2. These are our values there. This one's going to be our x1 comma y1. So when I substitute my values in, my value of y2 is -9. My value of y1 is -4. And then I go to my denominator, and my value of x2 is the number -6. And then my value of my my x1 is 3. So now I just simplify. So I just simplify the numerator, right? Negative and negative, this becomes a plus sign here, right? Negative times a negative is a positive. So -9 plus +4, this gives me -5 over, and then I have -6 minus 3, which is -9. So this simplifies to a +5 over 9. So this is my slope. So if I was to graph a line through these 2 points, I would get the slope of 5 over 9. So I would have to go from one point, I'd go up 5, and then to the right 9. All right, so our next form for our equation of lines is point slope form. And just like y-intercept, your slope, not your y-intercept, your slope-intercept, your slope gives you the slope-intercept gives you the slope, and it gives you the y-intercept. Your point slope form gives you a point and a slope on the line. And so we're going to say the point is x1 comma y1, and then m is our slope. You can say this is our point here if you want. So our point is x1, y1, and then m is our slope. What the form of the equation looks like is this. y minus y1 equal to m times x minus x1. All right, again, slope is your m, so that's what will go there. Your x1 and y1 will come from a point on the line. And then x and y are values that when you're trying to find, hey, if the x value is 3, what's my y value? Or vice versa. When my y value is -6, what's my x value is going to spit out to be on that line? And that's what we're going to use that x and y for. So example 2 now, it says find the equation of a line that passes through the point -1, 4 and has a slope of -3/5. So first off, what we want to do is we want to just simply write out what we have. Okay, so we have a point and we have a slope. So what we're going to do is we're going to say y minus y1 equal to m times x minus x1. So remember this over here is x1 comma y1. Remember this is our slope, this is our m, right? So this stays as y. Our y1 is 4 from the point, right, from the point over here, 4. Our m is -3/5. And then our x stays the same, and then x1 is -1. So as we keep moving along through this, we say here, that's a plus, right? Because it's negative times a negative. If we wanted to do it that way, which you totally can. So we have y minus 4 equal to, and what I'm going to do is I'm going to distribute this. I don't really need, I guess I probably didn't really need to do this here. You could probably have kept it just as what it was. Probably a little bit easier. And then I'm going to distribute that in there. So -3/5 times x is -3/5 x. Okay, but now I have -3/5 times, it's not -1, it's +1 here. So that's where the positive comes in handy there. So I have -3/5 times +1, which is -3/5. Now what you're going to do next is you want to try to solve for y. So to solve for y, I'm going to add 4 to both sides. And why I'm doing this is, I guess I should have said in the directions, I want you to put it in slope-intercept form. The text will ask you to put it in standard form. That's what the text knows it as, is standard form, but we're going to call it slope-intercept. So anytime you see standard form, I want you to think slope-intercept form. So now that I'm adding the 4 to both sides, I kind of have some scratch work here. I have this right here. I have a fraction, which is -3/5 plus 4. Now, what do I do with this? Well, I have to have common denominators. So in order to get common denominators, I need my 4 to have a denominator. And so I'm going to make 4 become 20 over 5. Now, why did I make 20 over 5? Because 20 over 5 simplifies to 4. Or did I come up with this? What I did is I said, okay, well, if my denominator has to be 5, and I have a whole number of 4, what's 4 times 5? And that's 20, and then it has to be over 5. So now you have -3/5 plus 20/5, which is positive 17 over 5. And then now what you're going to do, this is your backside. So I have y equal to -3/5 x, and I'm going to pull this over here, which is positive 17 over 5. And there is our equation and our slope-intercept form. Went from point slope to slope-intercept. All right, another definition here. First off, we have to know what parallel lines are. Okay, parallel lines are lines that do not intersect. So how do they not intersect? They do not intersect if they have identical slopes, or we could say the same slope. Right, you'll hear the term same. Now, two lines are perpendicular. That's where they intersect at a 90-degree angle. Then they have opposite reciprocal slopes. What opposite means, what I mean by opposite, is I mean the change in sign. So positive becomes a negative and vice versa. Reciprocal, the easy way to say it is the term flip. So what I mean by flip? Well, if I had 2/3, then if I flip it, it would be 3/2. It flips the fraction. If I had a whole number like 5, it would flip it to be 1/5. Why? Because really there's a 1 underneath that 5. We just don't write it ever. Okay, so example 3 says, find the equation of the line through the point 3, -5 that is parallel to the line whose equation is 2x plus 4y equal to 7. And the key word right here is parallel. Because parallel, based on our last definition, is we need to make sure they are the same slope. Well, first off, it says here's a point, and it has to be parallel to this other equation. Well, I don't even know the slope to this other equation. I must find it. In order to find it, I have to write it in slope-intercept form. It's the easiest way to do it. So I have 2x plus 4y equal to 7. And I'm going to solve for y. That's what gives me my slope-intercept form. So I'm going to subtract the 2x over. And I'm left with 4y equal to -2x plus 7. Solving for y still, so I'm going to divide by 4. Everything by 4. And we're left with y equal to, we're going to reduce that -2/4 to be -1/2 x plus 7/4. Now don't be frightened by this 7/4. We don't even use it. All we care about is this right here. That's our goal, this -1/2. Well, we want parallel, so which means we need the exact same slope. Okay, great. So we have the point, and we have our slope now, which is -1/2 because it's parallel. Now what do we do with it? Think about it. We have a point, we have a slope. We're going to put it in point-slope form. Our point-slope form, again, is y minus y1 equal to m times x minus x1. And then we're just going to substitute the values in. So I have y minus, in this case, my y1 is -5. Slope is -1/2. And then my x value is 3. Again, I'm just pulling this from the point and the slope that we have written right above it. Right here. And now I get to simplify. This becomes a plus, right? A negative times a negative is a positive. So you get y plus 5. Again, I should have said put in slope-intercept form. Your text will say standard form. So now we're putting it in slope-intercept form. Equal to, I'll distribute that -1/2, so I get -1/2 x, and I get plus 3/2. Now I'm going to take and move the 5 over. That's my last step, and I now have some mental math over here that I have to do. So I have 3/2 minus 5. So I need to make sure they have common denominators. So I'm going to say 3/2 minus 10/2, because 10/2 does reduce to be 5. So now that I have common denominators, I just add my numerator. So it's 3 minus 10, so I get -7/2. So my answer here is y equal to -1/2 x minus 7/2. This is my equation of a line through the point 3, -5, and it's parallel to the line of the equation 2x plus 4y equal to 7. Now what I did is, the next example is almost identical. You don't have to do a whole lot more here. If you look at it, it says find the equation of the line through the point 3, -5, which is exactly the same thing, but now it's perpendicular to the line whose equation is 2x plus 4y equal to 7. So what I'd like you to do is try to start it off on your own. See if you could do this. I'm going to pause it so my screen goes black, and then I'm going to get you to where you need to be. All right, so you can see that my starting point is exactly the same thing. I have my equation 2x plus 4y equal to 7, and I have to put it in slope-intercept form first in order to find my slope. But this time it's perpendicular, which means that it is not the same, it's opposite reciprocal. So opposite reciprocal, if I have -1/2, what is opposite? Opposite means it's positive. Reciprocal, I'm going to flip it. So 1/2 becomes just 2, or 2 over 1. All right, however you want to write it. But I'm going to write it as definitely 2. So now when I go to my point slope form, because now my point is 3, -5, and now my slope is +2, when I substitute it in, it looks something like this. What's nice about this one is I have no fractions, so I don't have to worry about side work of any sort. So I'm going to, remember, a negative times a negative is a positive, so it's y plus 5 is how it looks. Oh, I should distribute this, I'm sorry. I'm going to distribute the 2, so I get 2x minus 6. And then I'm going to subtract the 5 from both sides. I end up with y equal to 2x minus 11. And there's your equation again in slope-intercept form. Or in our case, in our text, it calls it standard form.